Welcome to Mr. Brown's Basement, a channel devoted to sharing the craft of repairing, restoring, and modifying vintage electronic gear, and other random stuff.
Today I'm going to be sharing with you one of the toys that helped cultivate my interest in how things work and in electronics in general. Before I do that, I'm going to show you my first piece of test equipment. I think I got it when I was about 4. My first piece of test equipment, as you see, very advanced. The way it works is you get a battery and connect it to the bottom and the top, and there we go. And while that may not be all that exciting now, to a 4-year-old, this was both ooh and ah, all at once. But this video is not about my first piece of test equipment. This video is about a toy that I remember from when I was a little boy. My Edu-Electronics Kit. I don't know whether there was a Model 8 or a Model 6, but this is Model 7. This is not the original one that I had. I played with that one so much that I wore it out. There was not much left. But it wasn't malicious. It was that I just enjoyed it so much I wouldn't stop playing with it. So this is it. It's a box which contains a piece of plexiglass with some parts mounted on it. And underneath that, templates to make circuits, and there were 7 different circuits I could make. A lot for a 4-year-old. Morse code practice set, a wireless microphone, in other words a transmitter, a germanium diode 1 transistor direct coupling radio, a sleep-inducing apparatus, a germanium diode 1 transistor radio, a germanium diode radio, I guess you're seeing the theme here, and an audio amplifier, which unfortunately required an audio source, which I didn't have. What I'm going to do today is I'm going to test the transistor. I'm going to test the 2 capacitors. I suspect the electrolytic is probably bad. And the resistor. And I'm going to build one of these 7 things that I did just a few years ago. Let's test the resistor. It's marked red, violet, and yellow at plus or minus 20%, which is 270 kilo ohms. And measuring it at 345 kilo ohms. 270 plus or minus 20 would be anything between 216 and 324. It's a little bit out of tolerance. I'm not going to worry about it. Let's try the potentiometer. The entire element is about 467 K. Let's see if it actually works. Well, it works, but it's dirty. It probably hasn't been moved in a while. Look how it jumps. It jumped at one point to 600, which means there's a dead spot in it somewhere. Anyway, the potentiometer works. Better check the continuity on the transformer as well. Yeah, as expected. Primary has a DC resistance of 624 ohms, and the secondary is probably much lower than that. Yeah, 73 ohms. So that just leaves to test the transistor and the 2 capacitors. damaged part. Okay, it knows it's a capacitor, but it is unable to measure it, which means it's open, or very, very bad. Let's try it again. Damaged part. Okay, so that capacitor has to go. Let's try the next capacitor. This 0.01 looks like a paper and oil or something like that. I don't know. (9810) picofarads, which is just under what it should be. That's fine. This will work as a capacitor. Let's try the transistor. It is a PNP transistor with a beta of 5. That's not a lot. May not be enough. Let me see what transistor it actually is. Transistor is a Hitachi 2SA12. That's a very, very early germanium transistor made in Japan. According to 2SA12's datasheet, the gain should be about 70 minimum, and 5 doesn't cut it. So let me see if I have something which is equivalent to 2SA12. I don't have a 2SA12. The best I have is a Hitachi 2SA350. Looks the same and will do the same job. The capacitor is a Sankyo 10 microfarad 6 volt, what appears to be non-polarized capacitor, and it's axial. Probably can't get that now. Could get it in radial. Here's a radial capacitor. This one is polarized. 10 microfarads, 50 volts. I could probably stretch it and make it look like that. And that would do the same job, and I promise not to reverse the polarity on it. I'll just make sure that negative is connected up to negative. In case you're not familiar with germanium transistors, in this package it's called TO1 for transistor outline 1. There's often a triangle or a dot over one of the 3 terminals. That's the collector. So the way it's wired is emitter, base, and collector. And of course, on the capacitor, there's one side that's labeled minus, the other has to be plus. If it were non-polarized, it would have no markings at all, which the original has, but I don't have one. Well, there's not much of a difference for the way it's going to be used. The problem is that these components are, or were, connected to these studs before the studs were put in. So I don't think I can pull them out from the plexiglass and not damage the plexiglass. Instead, I'm going to cut the component and make a loop and solder the new one in. Not beautiful, not 100% authentic, but I don't think I can do this without damaging it. It was never intended to be repaired. I've got the new transistor in place. Bratton, Bardeen, and Shockley would be very, very proud. And I've got the new capacitor in place. Faraday would be proud as well. And now I think we can start building a circuit. It's got these clips that fit on the posts. Batteries I had back then were a lot more interesting than the batteries I have now, because there was real artwork on those batteries, and now batteries aren't known for their artwork. All I need is the earphone, and I promise to share. Okay. And even though it's a sleep inducer, I'll do my very best not to go to sleep while I'm making this video, or certainly not when I'm editing it. Okay, I think we're ready to go. That faint ticking is the whole thing. Maybe the code practice oscillator might be better. Let's try the code practice oscillator. I don't think this would have worked with the original transistor in place. It was just too weak to give any decent oscillation. I'm going to bridge the key because I can't hold the key down and the earphone up to the camera at the same time. Yeah, it works. Not exactly loud. I can't say that it's all that exciting now, but for a 4-year-old, or maybe 5, it really was. The instructions don't give a lot of information about how it actually works. Let me go to the code practice oscillator. Talks about telegraphy, shows Morse code. Now it is time for you to practice sending Morse code. Yes, and there's no explanation of this circuit, how the circuit actually works, just a transistor getting some feedback from a transformer. If I were to go back and talk to Mr. and Mrs. Eleco, I would have recommended some explanation and, of course, make it something that could be more easily shared, like having a speaker rather than an earphone. If there's sufficient interest in the comments below, perhaps I could be persuaded to make another video showing the other 5 circuits that could be made with this kit. I hope you enjoyed this video from Mr. Brown's Basement. If you did, please give it a thumbs up and consider subscribing to Mr. Brown's Basement for more interesting and unusual videos.